Hello and welcome to our today's lesson. In this lesson, I'm going to work on exercise 5.1 of Cambridge Primary Mathematics Workbook 5. And this exercise is about adding and subtracting decimals. Let's start working on each question. The first question in this exercise says, draw lines to join every pair of numbers that total 1. So we have some numbers around this ring, and before drawing lines to join them, I will show how we can easily find the complement of 1. We know that 0.1 plus 0.9 gives us 1, 0.2 plus 0.8 gives us 1, 0.3 plus 0.7 gives us 1, 0.4 plus 0.6 gives us 1, and 0.5 plus 0.5 gives us 1. If we consider the complement of 1, we can easily find the numbers that total 1. So at the top we have 0.5. We have to look around to find 0.5. If we have 0.5, we can join these two. If we don't have, we cannot join. So we cannot make 1 with 0.5. We see that there is no 0.5 over here. So it means we cannot make 1 with 0.5 over here. 0.9, the complement of 0.9 is 0.1. So we can easily join them, as we have over here 0.1 plus 0.9 equals 1. So we continue clockwise. 0.2 plus 0.8 is equal to 1. So 0.2 is here and 8 is here. Just joined. The other one is 0.4. Here we can see that 0.4 plus 0.6 is equal to 1. So we can connect 0.4 to 0.6. Well, and we have 0.7. 0.7 plus 0.3. Over here, 0.7 plus 0.3 gives us 1. So we connect 0.7 with 0.3. And we are done with the circle. But we don't have any other 0.5 to connect this one to get 1. Well, question 1 is solved. In question 2, it says, join pair of numbers that total 10. Here we worked on the complement of 1, but here we have to consider the complements of 10. The decimal part in the first number is 7, in the second number it's 8, and in the third number it is 6. We know that complement of 7 is 3, complement of 8 is 2, complement of 6 is 4. Now to find a number that can be added by 3.7 to give us 10, we have to look which number is ending in 3. So 2.4 cannot, 3.4 also cannot, because we have to find 3 in the decimal part. 4.2 cannot, 5.4 also cannot. Here we have 6.3 and 7.3. 6.3 and 7.3. You know that 7 plus 3 is 10. So if we add 7.3 with 3.7, it gives us a number more than 10. But 6.3 can give us a number which is 10 over here. So I connect 3.7 to 6.3. The other number, which is 5.8, we have to look for the number that ends in 2, because the complement of 8 is 2. So we see that the only number which is ending in 2 is 4.2. So we can easily connect them, because 2 plus 8 is 10. And we can write here, let me show it here, 5.8 plus 4.2. So 8 plus 2 is 10. We write 0 here and carry 1 above the ones place. 5 plus 4 is 9, and 9 plus 1 is 10. You see that this gives us 10. Well, the third number is 7.6. We see that the complement of 6 is 4. But we have three numbers ending in 4, 2.4, 3.4, and 5.4. If we add 7.6 with 3.4, it gives a number more than 10. 5.4 also gives a number more than 10. So the number that can be connected to 7.6 is 2.4. Let me solve this one also using the column addition. 7.6 plus 2.4. 6 plus 4 is 10. We write 0 here and carry 1 about the ones place. And 7 plus 2 is 9. And 9 plus 1 is 10. Again, we see that we got 10 over here. So we are done with question 2 as well. Let's scroll down to move to question 3. In question 3, it says, write the missing numbers. So we have part A and part B in this question. In part A, we have addition of decimals, and in part B, we have subtraction of decimals. We have to add 4.9 and 3.5 to get the answer in part A, and we have to subtract 3.5 from 9.4 to get the answer in part B. So to easily solve, I will use column addition. 4.9 plus 3.5. 4.9 plus 3.5. We add it the same way we add whole numbers. So 9 plus 4 is 9 plus 5 is 14. So 1 should be carried above the ones place. 4 plus 3 is 7, and 7 plus 1 is 8. So we bring down the decimal point. The answer we get is 8.4. This is how easy it is to add two decimal numbers. Well, in part B, we have 9.4. Let me write it. 9.4 minus 3.5. 3.5. We cannot subtract 5 from 4 because 5 is more than 4. So we borrow from the ones place. 9 becomes 8 and we get 14 over here. Now 14 minus 5 is equal to 6. We bring down the decimal point, and 8 minus 3 is equal to 5. So the answer in part B is 5.6. Well, question 3 is also solved. In question 4, it says, write the same number in both boxes to complete this calculation. If you remember, in the complements of 1, we say that 0.5 plus 0.5 gives us 1 because it says write the same number. So the same number that can be right here is 0.5 plus 0.5. So question 4 is solved. Let me scroll down to move to question 5. In question 5, it says write the missing numbers. Here again we have part A and part B. In part A we have addition, and in part B we have subtraction. So to solve the part A of this question, I will write using column addition 8.58 plus 2.91. In this part we have two decimal places. We have the tenths and the hundredths. So we start adding from the hundredths place. 8 plus 1 is 9. 9 plus 5 is 14. 1 we carry above the ones place. 8 plus 2 is 10, and 10 plus 1 is 11. 11.49. So the answer is 11.49. In part B, we have 7.82 minus 4.49. Let me write this one also in column addition. So 7.82 minus 4.49. So here we can see that in the hundredths place, in the second number, we have 9. 9 cannot be subtracted from 2. We can borrow from the tenths place. So in the tenths, we will have 7 and 12 in the hundredths place. 12 minus 9 is equal to 3. 7 minus 4 is also equal to 3. We bring down the decimal point, and 7 minus 4 is 3. So the answer we get is 3.33. The answer is 3.33. Well, we are done with question 5. In question 6, it says, write the missing number. So here we have 10 minus a number equals 3.45. To solve this, I will write here to the right part over here, 10 minus a number. I don't know what number it is, but the answer is 3.45. To find this number, we can simply subtract 3.45 from 10. So I can write 10.00. I have to give the decimal point in the decimal placeholders so that we should be able to subtract 3.45 from it. Minus 3.45. Now we can simply subtract 3.45 from 10.00. We know that we cannot subtract 5 from 0 and also 4 from 0. We borrow from 10. If we borrow from 10, we will have 9 in the ones place, and this becomes 10. Now, if we borrow from this 10, we will have 9 here, and the 1 in the hundreds place will become 10. So 10 minus 5 is 5. 9 minus 4 is 5. And 9 minus 3 is 6. To show that my answer is correct, I will subtract 6.55 from 10. So I will write here 10.00 minus 6.55. In the same way, we borrow from 10, this becomes 9, and this becomes 10 in the tens place. Again, we borrow from the tens place, this becomes 9, and the one in the hundreds place becomes 10. 10 minus 5 is 5. 9 minus 5 is 4. Bring down the decimal point, and 9 minus 6 is 3. We see that we got 3.45. So the answer we got is correct. So 10 minus 6.55 equals 3.45. Well, we are done with this question. Let me scroll a bit down to go to question 7. In question 7, it says, Ali, Ben, and Carlos calculate 9.2 minus 4.7 using different methods. The first one is Ali's method, then we have Ben's method, and then we have Carlos' method. In Ali's method, he has first estimated the answer. He used rounding to the nearest ones. 9.2 is rounded to 9, and 4.7 is rounded to 5. So 9 minus 5 is 4. 4 is the estimated answer. He has written the question again, 9.2 minus 4.7, and has used a number line. So in the number line, the point over here is showing 9.2. 9.2, and he has counted back 4 numbers and stopped at 5.2, and another 0.5 points to stop at 4.5. To stop at 4.5. And Ben has also estimated using rounding to the nearest ones, seeing that 9 minus 5 is giving 4, and he has then broken his number into whole numbers and decimal numbers, and then subtracted each one separately. So he has broken the first one, which is 9.2 to 8 plus 1.2, and 4.7 to 4 plus 0.7, and 0.7 is subtracted from 1.2, which is 0.5, and 8 minus 4 is 4. Again, he got 4.5 as the answer. The last one, which is the Carlos method, he also used rounding to the nearest ones to estimate. The estimated answer for him is also 4, but he has used column subtraction. He has first ordered them, putting the decimal points in order, and then borrowed from the ones place to get a complete number in the tens place, and then subtracted 7 from 12. He also got 4.5. But the case here is, it says, whose method do you like best? Explain your answer. All three of them have answered the best way actually, but I like Ali's answer. I can say I like Ali's answer, or I like Ali's method. Why? Because he used number line, which makes the method more understandable. The method more understandable. Okay. This is my idea. Maybe others like Ben's method, or maybe someone likes Carl's method. Carl's method is also the commonly used method which people use. So maybe someone likes Carl's because it is straightforward and he just need to borrow and calculate. Well, we are done with question 7. In question 7, we didn't have to do anything. We just needed to say whose method is the best one for us. Well, let's scroll down to go to question 8. In question 8, it says, Sophia makes designs using hexagons and small triangles. She gives each shape a value. In the first shape, she has 3 small triangles and 1 hexagon, and the value for that is 11. But in the next shape, she has 3 hexagons, and the value for that is 15. So here we can say that 3 hexagons equal 15. Now to find the value of 1 hexagon, we have to divide both sides by 3. Both sides by 3. So this 3 cancels out the one here. The value of 1 hexagon will be equal to 5. 1 times 3 is 3, and 5 times 3 is 15. So the value of 1 hexagon is 5. Now that we found the value of 1 hexagon, we can simply find the value of the triangles here. It says, find the value of a small triangle. So to find that out, we can write 3 triangles plus 1 hexagon will be equal to 11. We know the value of the hexagon, so we can write 3 triangles plus the value of the hexagon is 5, plus 5 will be equal to 11. And if we subtract 5 from both sides, 11 minus 5 will be 6, and this part minus 5 will be left with 3 triangles. Okay, now if we divide both sides by 3, here also by 3, the value of 1 triangle will be equal to 2. 1 times 3 is 3, and 2 times 3 is 6. So the value of 1 triangle is 2. I can write that the value of a small triangle is 2. This is the answer to question 8. I hope it makes sense for you. So let's go to question 9. In question 9, it says, here are 4-digit cards. 4-digit cards. We have 8, 4, 2, and 5. And it says, use each card once to complete the calculation. So in the whole number part, we have 0, and here also in the whole number part, we have 0. To make it 1, we have to put 2 numbers in the tens place that give us a 0. So we can write 8 here and 2 here, because 2 plus 8 is 10. And now we can write the other two, which is 5 and 4. It doesn't matter where we write. If we write 4 here and 5 here, they will give us the same answer. So now the numbers that I got, I will write here to find if it gives us 1 or not. 0.58 plus 0.42. 8 plus 2 is 10. We write 0 here and 1 carried above the tens place. 5 plus 4 is 9. 9 plus 1 is 10. Again, we write 0 here and 1 above the ones place. We bring down the decimal point. 1 plus 0 will be equal to 1. We see that we got 1 as the answer. So the numbers which are arranged here are arranged the right way. Arranged the right way. Well, we are done with question 9. In question 10, it says each side of a number balance has the same answer. Write the missing number in the box to complete the number balance. So we have 6.43 plus another number, which is equal to 8.49 plus 1.37. 1.37. So to find the number in the box, I have to first add these two numbers and subtract 6.43 from that number. Well, let me scroll a bit down. So 8.49 plus 1.37. Let's see what number we get. 9 plus 7 is 16. 1 should be carried above the tens place. 4 plus 3 is 7 plus 1. It is 8. Bring down the decimal point. And 8 plus 1 is 9. So on the right side of the balance, we have 9.86. To find what number we have in the box, we have to subtract 6.43 from 9.86. So 9.86 minus 6.43. 6 minus 3 is 3. 8 minus 4 is 4. And 9 minus 3 and 9 minus 6 is 3. So the number here is 3.43. If we add these two together, it should give us 9.86. Let's see. 3 plus 3 is 6. Okay, we have 6 in the hundreds place. 4 plus 4 is 8. We have 8 in the tens place. And 3 plus 6 is 9. So that's correct. We are done with question 10 as well. In question 11, it says, write the missing digits to make the calculation correct. We have two missing numbers in the first number or in the top number and one missing number in the bottom one. We have to find them out to get a total of 5. In the beginning of the video, I explained the complements of 1. The complements of 1 and also the complements of 10. So we have to look for the numbers that can be added to 2 to give us 10, so that we should end in 0 here. That number is 8. So 8 plus 2 is 10, and from 10 we write the 0 here and carry 1 above the tens place. 1 plus 2 is 3, and 3 plus 7 over here gives us 10. Again, 0 we write here and carry 1 above the ones place. The answer that we should find should be 5. 1 plus 2 is 3. And 3 plus another 2 gives us 5. Now, 2 plus 2 is 4, and 4 plus 1 is 5. So we are done with the missing parts of question 11 as well. Let's scroll down to go to question 12. In question 12, it says, use all the numbers 0.1, 0.2, 0.3, 0.5, 0.7, 0.8, and 0.9 to make the total of each line 1.5. If we add this line or add this line or add this line, it should give us 1.5. 1.5. To find it out, we can write 0.5 here, and we know about the complements of 1. We should write the numbers that add to 1, and that 1 plus 0.5 will give us 1.5. Starting from 0.1, if I write 0.1 here, 0.1, the complement of 0.1 is 0.9. 0.1 plus 0.9 gives us 1, and 1 plus 0.5 gives us a total of 1.5. In the same way, if we write 0.2 here, 0.2, 0.2 plus 0.8 gives us 1. So I can write 0.8 here. 0.2 plus 0.8 is 1, and 1 plus 0.5 is 1.5. So the number that I can get here is also 1.5. And the other numbers which are left are 0.3 and 0.7. 0.3 plus 0.7 gives us 1, and 1 plus 0.5 gives us a total of 1.5. A total of 1.5. So we are done with this question as well, and we used all the given 7 numbers to put them in a way that each line gives us a total of 1.5. Well, let's scroll down to go to question 13. In question 13, it says, Kate and Heidi each buy some fruit. In Kate's fruit, we have 3 apples and 2 bananas. And the price of all is 90 cents. And in Heidi's fruit, we have 2 apples and 2 bananas. And the price of all 4 of them is 70 cents. So to find out the price of 1 banana, because here it says, how much does a banana cost? We have to do some calculations. So let's write here. I will first calculate Heidi's fruit. We have 2 apples plus 2 bananas. 2 bananas equal 70 cents. If we divide both sides by 2, we can find out the price of apple. So we can write 2 divided by 2 will be 1. So we can write apple plus this one also 1 plus banana equals 35, because 70 divided by 2 is 35 cents. So now to find the price of banana, we can write banana equals 35 minus the price of apple. Now we can put the price of banana in Kate's fruit to find the price of the apple. Then we can easily find the price of banana. So let me scroll down. In Kate's fruit, we have 3 apples. 3 apples plus 2 bananas equal 90 cents. In place of 2 bananas, I will write 35 minus apple. So we can write 3 apples plus 2 for bananas. I will write 35 minus apple. 35 minus apple equals 90 cents. So 3 apples plus 2 times 35 will be 70. 70 minus 2 apples. 2 apples equals 90 cents. We did it by multiplying 2 inside the parentheses over here. So now let me scroll down. Here 3 apple minus 2 apple will give us 1 apple. 1 apple. And if we subtract 70 from both sides, we will get 20 cents. This means the price of 1 apple is 20 cents. Now to find the price of banana, I will put the price of apple here. The price of apple here and find the price of banana. Let me write it down here. Banana equals 35 minus apple. Let me write apple first. 35 minus apple. So we can write banana equals 35 minus 20 because the price of apple is 20 cents. Minus 20. So the price of 1 banana is 15 cents. Is 15 cents. This is how we could find the price of 1 banana. So I can write 15 cents over here. So with question 13 of this exercise, we are done with all the questions of exercise 5.1 of Cambridge Primary Mathematics Workbook 5. I hope it helps you learn how to add and subtract decimals. Please make sure to subscribe to my channel, like the video and share the video with your friends, your classmates and your students if you are a teacher. And if you have any question, ask me in the comment section under this video. Have a nice time and thank you so much.